Boozer, and I am with CUGC HQ, and I am so happy to welcome you to today's user share, talking about Citrix XenApp Disaster Recovery with NetScaler GSLB and Microsoft Azure Site Recovery. I know this is a popular topic, and a lot of people are interested in hearing about it. Can you skip to the next slide? Very quickly today, our format is a presentation with Q&A, which means that we'd like you to type your questions into the question panel in the GoToWebinar control panel. We will keep keeping an eye on those throughout the presentation, and just type them in as you have them. Also let you know that this presentation is being recorded and will be posted on mycugc.org tomorrow, and you'll also receive an email with a link to the recording, and you'll be able to watch it anytime on demand. And with that, I'm going to go ahead and turn things over to our presenters, and want to take it away, Christiaan?
Yes. So let me introduce myself. I'm Christiaan Brinkhoff. I'm a senior workspace consulting for D'Ieteren, departing in the Netherlands, where I'm serving their enterprise 500 plus customers on their application and desktop delivery Citrix environments. I'm awarded as VMware vExpert 2017 just last week, so I'm very honored to be part of that program. I'm also participating in the NetScaler MVP program, where you actually can win a lot of great prizes. I'm also participating in the Agile Community Tech Insider program, and I'm also the DEP-CC community professional for contributing my articles on. Next to my external contributor work, I'm also blogging my posts on my own blog page that can be found on infoshare.net. And next to that, I'm also sharing my in-field knowledge on my Twitter social channel, and that can be found at Brinkhoff_C. So switch over to Dave.
Hi there. So my name is Dave Brett. I'm based in Liphook in the UK. I'm a Citrix CTP, a CUGC network and SIG leader, and also a community contributor on dougsdabcc.com. I can be found online at bretty.me.uk and also on Twitter at @dbretty.
Hi, my name is Carsten Bruns. I'm located in Germany, in Lingen. I'm also a Citrix CTA, MyCUGC networking SIG leader, and Agile technology insider, and also login VSI VIP. I'm blogging on my company site, which is sepago.de/CarstenBR, and my Twitter handle is Carsten Bruns.
Okay, great, Carsten. So let's straight over to the agenda for tonight. First, I'm going to talk about the Azure components that are being used for activating the Azure Site Recovery environment and the NetScaler GSLB environment, which components are be used to activate the setup. Afterwards, I'm taking you down the runway of Azure Site Recovery services, including an actual initial configuration demo, so you get an impression, how easy it can be to set up an Azure Site Recovery environment. After that, Dave Brett will take you down on the NetScaler GSLB configuration and parts that are being used to use GSLB in Microsoft Azure, and also including an initial configuration demo. After that, Carsten Bruns is running you over the tips and tricks on NetScaler and Azure. So a lot of best practices are on that slide, so are pretty awesome. At almost the end of the presentation, we are showing you an actual failover. So we're simulating an outage in the on-premise environment, and we will fail over the XenApp and NetScaler proxy environment to Microsoft Azure. When we are done with that, we have a Q&A, so spare your questions to the end. And at the far end, we also have a competition quiz where you can actually win something nice. So stay tuned and pay attention on the content. And maybe you can also win some great pricing. So let's start. My opinion, organizations need to understand their disaster recovery risks more. I see a lot of companies in the field in the Netherlands that haven't got any disaster recovery environment activated. So they always ended up with a restore of an virtual machine from Veeam, for example, but doesn't have any recovery site or backup site where actually is a replication of their on-premise environment active. So that's a big risk in my opinion. And when something is going to happen in the on-premise environment and you can't recover it very quickly, you end up like the picture, like this picture. And in my opinion, that gives not enough confidence for your own environment. So as being an IT professional, you always want to be professional and always want to be satisfied and confident about your on-premise environment. So for the people that doesn't have any disaster recovery environment active, you can try this theory, but in my opinion, this don't gonna work. So be proactive and build an actual disaster recovery environment. And one of that examples is Azure Site Recovery that we're gonna talk about today on this webinar. So let's go to the next slide. Azure is almost everywhere. So this picture is very recent, and it's being used by several companies, also to Citrix as well. You can see that all the blue spots are actual Azure data centers. And back in the days in 2010, I guess, was when Azure was started up as Windows Azure. There were only three regions active, and that were reported in America, EMA, Europe, and Asia. And look at where we are now. There are actually 34 regions online now, and 4 additional are planned at the moment for building up and expanding. And it's growing every day. So it's pretty awesome. And it's also in the top 3 listed networks in the world. So you haven't got any excuses left to say that Azure is too far away from your on-premise environment, or the distance is too long. So Azure takes care of that all now. So no reason to doesn't migrate to Microsoft Azure. In the link at the bottom of the slide, you can find more information about the regions and where they actually are in the world. So to build up a site recovery environment in Microsoft Azure and the NetScaler GSLB environment, we are using the infrastructure service of all the Azure components. And in the infrastructure service, we are activating the storage account. The storage account is actually a place to store your data in. So the Azure Site Recovery environment construction also works on the storage account. In the storage account is all the replication data stored. So your on-premise virtual machines are replicated through the internet, later more in detail on this topic, and are being stored in the storage account. In some of the next slide, we are gonna more in depth on the storage account configuration parts and some best practices. We are gonna use resource groups. Resource groups is always being activated when you're choosing to activate components in Microsoft Azure. Resource groups can be compared with actual organizational units in Active Directory. it's a place where all your services are combined and bundled in, just to give a better and detailed explanation in your billing, for example. Also a requirement to activate is the Azure Virtual Network. Otherwise, we can restore any virtual machines. They need to be attached to a LAN network in Microsoft Azure. And you can also activate that Azure Virtual Network to your on-premise network, but later on more on that. Sorry. We also activate network interfaces that are also standard from virtual machines. Network security groups that are actually firewall entries on the network interface, so you can open internal and external traffic on NSGs, in short. And we are using availability groups to make sure your VM is deployed redundantly without risks to take over in case of an update or something like that. But also more later on that part of Azure. ExpressRoute, later more in detail. ExpressRoute is the VPN connection to Microsoft Azure from inside the data center. But I'm not going to talk very much on this at this moment. In 4 slides later, I will take cover this and also actually the IPsec VPN connection that are bundled in 3 parts. In our virtual network gateway, local network gateway, and then a connection to combine that to each other and to make up the actual connection to Microsoft Azure from inside your on-premise environment. And also part of the infrastructure service, the platform service of Microsoft Azure is the hybrid operations service, and inside that we are activating the site recovery service that is being used for the actual disaster recovery of our Citrix XenApp environment that we are going to build in the next slides. So here's a nice portal where you can see all the services of Microsoft Azure. And we are actually using this compute section for activating the virtual machines. We're using the storage section for the storage account, and the network section for the IPsec VPN or ExpressRoute, and the site recovery service under the hybrid operations for the disaster recovery replication. So let's start with what is Microsoft Azure Site Recovery, or ASR in short. Microsoft Azure Site Recovery is the replication software that can be used to replicate your on-premise environment to the Microsoft Azure public cloud. So it actually one-on-one replicates your virtual machines in your on-premise environment to Microsoft Azure. One of the biggest advantages of Microsoft Azure Site Recovery is that it is a good starting point to the cloud. So when you're actually activated Microsoft Azure Site Recovery, all your on-premise environment servers are prepared to move on to the Microsoft Azure cloud. So besides it's a good product for disaster recovery, it's also a great product to migrate or convert your on-premise environments, your workloads, to the Microsoft Azure cloud. So pretty awesome. I've been using it a lot for migrating servers for customers to the Azure cloud, and then decommissioning the site recovery construction, and I can let the virtual machines run in Microsoft Azure afterwards. It's also possible to do a single server failover. So you are not limited to only doing a full failover to Microsoft Azure, but you can also choose to when you're having a problem with one application server in your on-premise environment and you are not able to fix that problem, it's a hardware issue, or you need some extra resources, one hypervisor is down, you can also choose to fill over some single servers, run it in Azure, and afterwards fill back to your on-premise environment to stay up to date with your data. So that's one that I want to keep you in mind. There's no initial standby hardware needed. More later on in the next slides, but you for normal regular site recovery software, you have to build up an actual replica of your on-premise servers. So the same hardware, the same VMware licenses, for example. And with the Azure Site Recovery, you haven't need to do that. You can use the infrastructure as a service part of Microsoft Azure, and that's an Hyper-V hypervisor layer on the background, and that's all included in the cost. So pretty awesome. Also keep in mind that fillbacking is also possible. Just don't think that you are only allowed to fill over to Azure and then you are stuck with Azure and you don't know what to do and how to come back to your actual on-premise environment. So fillback is also possible. It supports the most common hypervisors. In the next slide, I take you down on all the versions that are supported in Microsoft Azure. Almost every workload is supported, so even Linux machines are supported in Microsoft Azure. So you are able to replicate your Red Hat or your Oracle service, for example. So also pretty awesome. And it's easy to implement. So in the next few slides, I also show you an initial configuration demo. So you can see how easy it is to implement Azure Site Recovery. And afterwards also including Citrix XenApp to implement for both services. And Microsoft takes care of the rest. So you only need to replicate and activate the machines in the on-premise environment, and Microsoft takes care of the rest. So the hypervisor layer on Microsoft Azure is taken care by Microsoft. So it's also saves you a lot of time for managing and maintaining the actual site recovery environment. And another tip for me is for you is that you can use Azure ASM, the Service Manager portal, and the ARM, the new portal where actually all the new releases and innovation are activated into. Always use ARM. The ASM portal is depreciated, and actually there's no end of life date yet, but it will come very soon, I guess. So companies are migrating now from ASM to ARM. So keep in mind that you always activate Azure Site Recovery in Azure ARM. So supported hypervisors. To activate Microsoft Azure Site Recovery, we can choose to use Hyper-V, Hyper-V standalone, and Hyper-V in combination with System Center Virtual Machine Manager 2012 R2 and 2016. You also be able to configure and activate it on the VMware platform. And that's the result of the acquisition of the company Image back in 2012, out of my head. And that is a company that was specialized in VMware, VMDK to VHD, VHDX replication and converting. So with that acquisition, Microsoft exceed their strategy level up. So more people are now allowed or are now able to actually convert and migrate to Microsoft Azure, even when they are on a VMware hypervisor environment in their on-premise environment. So yeah, that's pretty great. And yeah, for using that, you are limited to versions 6.5, 6.0, 5.5, and 5.1 with the latest updates installed. And my demo in the next slide is also related on VMware, just because my home lab environment is working on VMware vSphere. So next to that, it is also possible to replicate physical servers. On that physical server will be an agent deployed that will be replicated to the internet. So yeah, also more in detail in a later slide on that. And we also have Azure to Azure Site Recovery, what is still in preview, but you are with that option you are able to replicate between different data centers of Azure in the same Azure subscription. So for example, you have your primary full public cloud workload in Microsoft Azure, and you want to activate a site recovery, disaster recovery option. You can also replicate your environment that is departed in Amsterdam, replicate to Asia, China, for example. So yeah, that's still in preview, but more and more customers are migrating to public cloud environments. So yeah, this will be the future, I guess, for disaster recovery and business continuity. And yeah, at the end, unfortunately, XenServer is not supported. So, and I also think that it's never gonna happen to make it supported. So you are stuck with Xen convert and to convert it to the Microsoft Azure Cloud. So let's move on. Supported replicated operation systems. To replicate your virtual machines, they are limited, or it is required to have the following operating systems active on that virtual machine. The first one is Microsoft Server 2008 R2 SP1. That's the starting point. So when you still have 2003, for example, Azure Site Recovery is not going to happen for you. So you still need to migrate to 2008 R2. But I assure you that you better can choose to pick 2016 or 2012 R2, for example. 2002 R2 is supported. Actually, Windows Server 2016 is only yet supported for Hyper-V and Hyper-V System Center Virtual Machine Manager. It's not officially supported for VMware and physical machines yet, but it's coming soon. So my demo is also taking down on Windows Server 2012 R2, but it's coming soon. So I hope that Microsoft is building up a fix for migrating Windows Server 2016 in the next month. And also mentioned in 2 slides before is Linux is also supported. So you're also able to migrate your on-premise application or database servers that are running on Linux. And only the following 5 operation systems are then supported with the version numbers that are listed. And when you want to need more on the supported operation systems, please click on the link in the corner when the slide is after the session is being shared with you. So now I want to talk more about Azure networking. As mentioned in also another one of the first slides, Azure networking can be activated in several ways. One of them is Azure Virtual Networking on IPsec VPN tunnels. And that's the simplest way to connect your on-premise firewall or router to Microsoft Azure. It's relying on the IPsec protocol, so it's very easy to implement. You need a virtual network gateway in Microsoft Azure, local network gateway, and an actual connection and a virtual network, a VNet in Azure. You combine them in the connection, and afterwards you can connect with phase 1 and phase 2 to the IPsec VPN tunnel. So that's the most easiest way, but not the most reliable way to activate. So to get more reliable and to use a more SLA-based connection, you can activate the Express route. And Express route is an MPLS BGP VPN connection from Microsoft Azure to one of the secondary data center vendors that are involved with the Express route program, that are also being known as the partner edged in the drawing. And with the Express route, you are building up a circuit on BGP on the background, and that's translating the routes to the edge routers of Microsoft Azure and the edge routers of your partner data centers. And some of the partner data centers are, for example, Equinix or T-Systems. And then you have to work from your on-premise environment, with your networking ESP provider to include the on-premise routes with the Microsoft Azure VPN Express routes in the BGP session. So this one is pretty reliable and can be used in SLA in SLAs with your ISP. And Microsoft guarantees a 99.9% uptime on the Express route. And the Express route can be activated in 3 separate ways. You have the Microsoft peering, and the Microsoft peering holds down all the routes of Office 365, for example, Skype for Business Online, and Dynamics 365. So when you are activating the Express route, you can choose for 3 peerings, and when you choose for the Microsoft peering, you can connect internally directly through the Express route from your on-premise environment to the Office 365 services, Skype for Business, and Dynamics 365. Afterwards, you can also choose for the public peering, and this one is more common for the Azure Site Recovery, just because when you activate the public peering on Microsoft Azure, you can connect through the BGP peerings, through the routes internally to the Azure storage account. So what that means is that your replication from your on-premise environment to the Azure Site Recovery service in Azure is not taking place over the internet, but it's taking place over the Express route, over the internal route, over the circuit connection. So when you are choosing for Azure Site Recovery and you have you need a reliable connection to Microsoft Azure, you definitely need to take a look at the public peering. And now comes the most simple way, and that's the private peering. And with the private peering, you can actually do the same as the IPsec tunnel. You can connect your on-premise networkings to the Azure VNet network, but then on the reliable SLA 99.9 uptime connection. So, sorry. Keep that in mind. I need to say that the Microsoft and public peering are not normally available for everyone, and Microsoft requests to do a network assessment before you actually can activate or can be discussing this with your representative of Microsoft. Yeah, just after you did a network assessment. So yeah, when you are interested in this, yeah, please contact your Microsoft representative to yeah, get more information about that. And next to these two built-in options of Microsoft Azure, you also can yeah, connect from your on-premise environment to NetScaler SD-WAN in Microsoft Azure to build up a VPN connection to your virtual network. So yeah, also at the bottom of the slide, you can find a YouTube video that was actually part of this presentation, but just to make it not too big and not too long in time, you can run the video afterwards, after the session, to see how you can connect an IPsec VPN tunnel in Microsoft Azure and which components you need to activate then. So yeah, more deeper explained about the Azure Site Recovery. Azure Site Recovery is working from your on-premise environment through a management server, and that management server is replicate the data from your virtual machines in your on-premise environment to Microsoft Azure. So over the internet or through the express route when you're using the public peering. And that management server can be a virtual or physical one. It's what you want. But that needs to be available in your on-premise network, and it connects to the actual vCenter server for activating the replication between your virtual machines in VMware, for example, to Microsoft Azure. And on that management server, there's running a process server, and the process server is actually the server that acts as coordinator for data transfer between the site recovery services and your on-premise environment. So it's translating the virtual machine data to Microsoft Azure. And the master target server is the server that is being used for creating the replicated data in an actual virtual machine in Microsoft Azure, or when you're doing a fallback in the on-premise environment. Also being said that it's replicated to the over the internet or over the internal express route network when you're choosing to pick the public peering. And also keep in mind that if you are initially activating Microsoft Site Recovery and you activated the servers on the environment, the initial configuration always pick the maximum bandwidth of your environment. So be careful with that and use bandwidth throttling software for that, or an appliance or load balancer, quality of services appliance, or a firewall appliance that can throttle your bandwidth. Otherwise, your full internet connection will be taken down. Other important notes is RPO and RTO. RPO stands for Recovery Point Objective, and RTO stands for Recovery Time Objective. And Recovery Point Objective is the explanation, the name for the changes in your on-premise environment and your replicated environment. So, for example, when your application server is a database server and one user is placing a database entry in that database, the RPO stands for the setting that the replication time is the default time that needs to be held at Microsoft Azure. So the changes in between, the time in between for the on-premise and the replicated environment. And the RTO stands for the actual time that it takes to restore your environment in the site recovery environment. So yeah, it's depending on the workload. So yeah, how bigger the workload is, how longer it takes to start up the whole environment in Microsoft Azure. The most lowest configuration of the RPO is 30 seconds. So yeah, when you are choose to configure 30 seconds of changes in the on-premise and the Azure recovery environment, then your bandwidth is pretty high. So keep in mind to play with that and check the capacity of your on-premise environment to make sure you're not creating too much bandwidth, then or you have to expand your internet connection. Also, the RPO and RTO is setting up in the recovery policies. In the demo, I will show you how to set up a recovery policy. But in the recovery policy, you set up the configuration of the RPO and the RTO. And the recovery policy also holds down the configuration of the failback. And that being said, you also have the option to choose for multi-consistency snapshots. What is being used for application and replication. For example, when you are using an application server and an application database, and the timestamp of your application server is different of the timestamp of the database server. Some applications are too sensitive for being not the same date and time of the restore, and then it can collapse and services can crash. So for that reason, there's a multi-consistency snapshot possible. So you're creating actual groups and you're placing database and application servers in the same group, just to make sure that the server and the database are in the same timestamp. So now more on Azure disk types. Before August, it was not possible to replicate partitions or disks in your on-premise environment larger than 1 terabyte to Microsoft Azure. It was possible, but then you need to partition them in separate disks and bundle them in a RAID setup, for example, a software RAID setup. But that's not the way that I like it to do. So after this month, during this month, Microsoft added the support of 4 terabyte disk sizing on Microsoft Azure for data disks, and 2 terabyte disks for operation system disks. So that's a pretty great advantage of the site recovery service. Next to that, you can also activate different kind of storage account related configurations. One of them is the local replication, and that means that you can actually replicate your data in your Azure data center 3 times. So when you store your on-premise replication virtual machine to Microsoft Azure, the actual replicated data in Microsoft Azure is also being stored 3 times in the local data center of Microsoft Azure. That's an option on the Azure storage account. So when you want to activate this as optional through the normal replication, you have to reactivate that on the storage account. The same is for the zone replication service, what means that you are actually replicate your data in 3 other data center regions of Microsoft Azure, and also on that other data centers 3 times locally. So yeah, that's also an extra way to make sure your data is always available in case of an outage of an actual Azure data center. You also have a GOS, it's a GeoWise replication service, what stands for geographically. So another zone in the world where Microsoft Azure Data Center is active is being used for replicate your virtual machine data to. And it's also in that geographically data center is also 3 times replicated locally. So another more reliable option to secure your data if the Azure data center is causing because a natural disaster or something like that. And the RA stands for read only, and that's just the same as the GOS option. We also have managed disks. Managed disks are the advanced disks method in Microsoft Azure, what includes more actually no limitations. So disk encryption is activated by default. So just for security reasons, that can be very useful. There are no IOP limits, so you are actually allowed to activate SSD storage exceed your speed of your environment. Another option that is available is disk snapshots. So you can actually just like you are used to be able on our on-premise hypervisor, you can use snapshots to restore to a earlier date and time of your virtual network, of your virtual machine. And it's also supported to activate Azure Backup, so you can also restore to later restore points in Microsoft Azure Backup. So here's a technical drawing of the actual Azure Site Recovery setup when you choose to activate it for VMware. On the lower side, you can see that there are some management servers activated with the process server, configuration server, and the management of the master target server active on that server. And what actually is take place is the management server is connecting to the vCenter server of VMware, and with the vCenter server it discovers your environment, and then an agent is being deployed on the servers that you want to replicate to Microsoft Azure. And then the replication takes place from the storefront server, for example, to the management server. And from the management server, it's replicated over the internet to the Azure storage account, to the storage blob service of the Azure storage account. So, as that being said, the VDA is the master image of your Citrix XenApp environment, and that is also it also needs to be replicated to Microsoft Azure through the management server. So more in the demo later on about this how this actually is being activated. And here's a technical insight of the actual failover of the virtual machine System Center Virtual Machine Manager. It's a little bit different. The recovery services agent is just as the VMware setup is installed on the servers, and it's replicated also through the internet or over the express route public peering to the Azure Storage Blob account. But now the virtual machine manager server is being used to orchestrate everything. So the management server, so the process server master target server, is now take place by the virtual machine manager server. So some useful tips on Azure Site Recovery. Just because Azure virtual machines are infrastructure as a service, so you are not allowed to connect to the Hyper-V background environment. So you also always be limited to connect to your servers to RDP. So always make sure that you activate RDP before you replicate to Microsoft Azure. When you have stricted firewall rules in your virtual machine, also make sure that the virtual network in Microsoft Azure is also added in the rules. Also keep in mind that when you choose to configure Azure Site Recovery, make use of DNS records that are being dynamically updated. So you're not required to change all the static DNS records after the failover. Just because your IP address normally changes when you fail over to Microsoft Azure. When you choose to activate it with an IPsec or express route, you cannot connect your on-premise environment on the same subnet A, B, or C section to Microsoft Azure. So that needs to be different. Otherwise, you can't connect to the VPN connection. And change the internal TTL, the time to live of your DNS records to 5 minutes, for example, just to make sure that all the DNS records, when you fail over to Microsoft Azure, are automatically being updated. So you are sure that when you start up the actual environment in Microsoft Azure, you are able to connect to all these services. Also, one tip is that use public DNS forwarders. So when you fail over to Microsoft Azure and you fail over your Active Directory server and you have a DNS forwarding active that is only accessible through your on-premise environment, only accessible through your ISP network, then when you replicate to Microsoft Azure and you fail over to Microsoft Azure, then your DNS, your external DNS isn't working then. So use public DNS forwarders. Also keep in mind that OS disks are only supported as basic disks. So keep that in mind. And only data disks can be dynamic. Also, another option of Microsoft Azure I want to mention is Azure Store Simple. That is the file server service in Microsoft Azure to replicate a physical file server of your on-premise environment to Microsoft Azure. So if you have a large file server and you want to replicate it through the Azure Store Simple, you can choose that option as well. But I don't take enough time to explain the actual Azure Store Simple for now. So keep in mind that you can replicate your on-premise Store Simple appliance to the virtual appliance in Microsoft Azure, and also use it for disaster recovery reasons in site recovery. And another tip is to test the failover multiple times in a year. So when your workload, your on-premise workload is changing, you upgrade software or implement a new software application. Check and test your failover multiple times a year, just to make sure that you're not stuck when you are failover with some software problems that had been solved before the actual failover happens. Another interesting Excel sheet is the capacity planner that is activated by Microsoft officially. When you are activating Microsoft Azure Site Recovery, you have an option to download this actual Excel sheet, and you can give up the numbers of your on-premise environments, your total numbers of virtual machines, your VHDs, the average size of your VHDs. And when you fill in all the information, you can actually see which bandwidth you need to use to activate and replicate your on-premise service to Microsoft Azure Site Recovery. It's very interesting, and keep in mind that this is very useful just to make sure that you're not have some troubles after activating with bandwidth or other related stuff. Another great option of Microsoft Azure Site Recovery is the recovery plan that I mentioned earlier. In the recovery plan, you can actually create startup boot sequences. So in the screenshot, I created a group 1, group 2, and some manual steps in between. And what it actually does is in group 1, it activates the Active Directory server. Afterwards, I have input a pre-step with a manual action where I try to RDP the Active Directory server, just to make sure that afterwards all the servers that needs to connect with the domain controller are being activated at the right proper way. Another great option of the Azure recovery plans is that you can insert automation runbooks. Automation runbooks are actually PowerShell scripts that can be deployed in Microsoft Azure, and also in the recovery plan. So when you have application servers that needs to update some settings after the failover, just update DNS records, for example, or other stuff is related that is required to make the application actually work. Then make use of automation runbooks just to take all the manual actions away. So you actually only need to click on the start button and have to wait. That is the perfect way of configure. And some PowerShell scripts that I found useful are the set Azure VNet to Azure DNS and the set Azure VNet to custom DNS. And with the first one, you can set the Azure VNet DNS settings to Azure DNS servers. That is required for the pre-step group 1. And after group 1, you can activate the set Azure VNet to custom DNS, and you can actually configure the internal DNS IP address for your environment, your Active Directory server. And on the right side, you can see how you can activate the automation runbook. So you can choose to use an automation account name and a runbook name, and a runbook name is actually a PowerShell script on the background. What about pricing? As said in the first slide, no virtual machine resource charging costs are active. They are only active when you are actually are being failover to Microsoft Azure. So when nothing is going to happen and you have no troubles in your on-premise environment, you have only the $25 or 30 euros in Europe, I guess, of the pair protection, this pair virtual machine that is being replicated to Microsoft Azure as costs. Also keep in mind that Azure Site Recovery is free to use for the first 31 days. So when you are starting up a proof of concept environment, for example, you are free of being activate that for the first 31 days. Replicating between Azure data centers is cheaper. It's $16 or 20 euros out of my head, I guess. And it's also nice to mention is the tweet of Prasanna of 13 December, where he mentions the new way of thinking of our public cloud replication. He said own 2 cars in case one fails. Buy rental car coverage insurance. What actually means is that you have actually 2 cars, but you only pay one. When in case of a failover, you can use the second one, and you only pay when you're using the second one. So yeah, I thought that that was be nice to show to you. Also keep in mind that Azure also provides support contracts, and when you are activating Azure Site Recovery, your company can require SLA for support, just to make sure when there are problems active, you get the proper help at the right time. And Azure for companies that need more help and shorter times for being helped, there is actually a Premier contract, and with the Premier contract you can buy additional services with lower duration SLAs for being helped. That's it. It is pretty expensive, but the help is pretty good. So keep that in mind. Also interesting is the Azure Hybrid Use Benefit Program. With the Azure Hybrid Use Benefit Program, you can actually use resources in Microsoft Azure with a big discount of up to 40%. And it is required to have an enterprise agreement with Microsoft Azure and to have a software assurance on that specific licensing. So when you, for example, use a Windows Server 2016 data center in your on-premise environment on the enterprise agreement with a software assurance activated, you can save up 40% on your Azure resource costs. So pretty awesome. When you are choose to do that, you need to activate the hub option in the Azure Site Recovery environment. More in the demo in 4 slides later. So pay attention, and I will cover that in the demo also. So now switch over to Citrix XenApp in Microsoft Azure. To activate Citrix XenApp in Microsoft Azure, you have 2 types of host connections that are available. One is the Microsoft Azure host connection that connects actually to the Microsoft ARM Azure data center. And the other one is the classic one, and that's connect to the Azure ASM data center. As being said, that ARM is the way to go at this moment, or at this moment it is the way to go. Please choose for Microsoft Azure. And with that in mind, there are 2 approaches of replicate your actual Citrix XenApp environment to Microsoft Azure by using the Site Recovery service. And one of them is creating a standby environment in Azure Infrastructure as a Service. So you're actually creating a XenApp environment in Microsoft Azure that always be standby active in Microsoft Azure. Or you can choose to replicate the master image in the on-premise environment. And that is the way that we are using in this demo on the next slides. What it actually means is that you make a replication in the on-premise environment of your master image, and on that replication you are activating the agent, the site recovery agent, and with that agent, it's the master image will be replicated to Microsoft Azure. And in case of a failover, the master image will be created in Azure Infrastructure as a Service. And afterwards, you can choose with your desktop delivery controller to activate the host connection to Microsoft Azure, and then deploy the machine catalog based on that replicated master image. I will show that you this all these steps later on in this session. So stay tuned. And you also need to be sure that you sysprep the machine just before you replicate that in the on-premise environment. And before you create the machine catalog, make sure that your shutdown status in Azure is on deallocated. Otherwise, your deployment will be crashing and will be running a failure. Another method that will be interesting to know is that the only way that the machine catalog can be activated in Microsoft Azure is through machine creation services. Citrix provisioning services is not supported in Machine creation services is supported. This information can be useful at the end of this presentation. Just being said. As I said, the replicated master image in Microsoft Azure needs to be selected when configuring the actual machine catalog on the VHD URI that can be found in the left corner. So this is useful information when you watch the initial configuration demo later on. Some user session density information. When you choose to activate XenApp in Microsoft Azure, there are some login VSI measurements active that can be found on the internet. These two graphical drawings are from Windows Server 2012. And here you can see that the D12 version 2 are actually the most users and cost-related configuration that can be used in Microsoft Azure. So keep in mind that the D12 version 2 is the most reliable, highest density sizing, and the lowest cost for configuring Citrix XenApp in Microsoft Azure. Also very useful is the cost calculator for XenApp on Azure. This one is created by Prasanna, so big thumbs up for Prasanna and his engineering team. This is free, available for everyone, and with that calculator you can calculate the cost of your actual XenApp environment in Microsoft Azure. So very useful information to share. So let's summarize all the steps that are required to activate Microsoft Azure Site Recovery and Citrix XenApp and NetScaler GSLB. First off, we need to review the prerequisites, the on-premise architecture, and plan the capacity. Here you can use the actual Excel sheet that I shared with you in some previous slides. Then we go to the prepare Azure resources. So your Azure Site Recovery preparation that I'm going to show to you in the next demo needs to be done. Then we need to prepare the hypervisor layer. So we need to make sure that every, for example, VMware vCenter or VMware vSphere ESX server is on the software level that is required, or the VMware level, or the Hyper-V level, for example. Then we need to activate the recovery services vault in Microsoft Azure. Then we need to configure sources and the management server. Then we need to set up the replication policy. The mobility agent needs to be installed. Enable protection in Microsoft Azure. So the actually server is activated then with the protection configuration. Then we can activate the NetScaler VPX in Microsoft Azure and configure the ICA proxy and the GSLB configuration. Afterwards, we can run an actual test failover. Then we need to configure the master. We need to prepare the machine catalog configuration for the master image, and then we can work in Microsoft Azure. So these are actually all the steps that needs to be taken to actually build up a Microsoft Azure Site Recovery environment with Citrix XenApp and NetScaler GSLB. So now we can switch over to the video. Just to say before we start with the video, I speed up a little little things. So some things will be actually pretty fast. And also the starting point of this video, this demo, is I already activated the management server. So the management server is actually a next finish installation. And just to spare out some time, I already did that. So this is the 2012 VMware management server that is being activated on my home environment, and I'm also configured the managed accounts that you're now seeing in the screen. And there I'm connecting from the management server to the vCenter server. So let's start. So here I normally need to add the vCenter account. So this needs to be an administrator account to the vCenter environment with the administrator rights. Then we switch off to Microsoft Azure and search for recovery services vaults. I already activated the vault, but normally you would click on add, name a vault, subscription, resource group, and a location of your data center. And then normally click on create, but I already did that. And now are we at the initial configuration of Microsoft Site Recovery. Click on getting started Site Recovery and then prepare infrastructure. And then on protection goal, and then you choose your location. It's on premise. Where do you want to replicate to Azure? And are your machines virtualized? Yes, with VMware. Here can I choose the configuration server, but normally you will click on plus configuration server and run this whole wizard. And you can down the Microsoft Azure Site Recovery Unified Setup, and that's the actual next finish installation. Afterwards, you input the vault registration key, and you're almost good to go. Then you connect with the vCenter of the vCenter server vSphere host service account that I was showing to you. And this will be used to discover all your on-premise servers to install the agents on and to activate the replication. So now the vCenter server is being added, but I already did this, so I can ignore this one. Now I choose to use a storage account and the actual portal that is being used. So choose resource manager, activate the storage account that you want to use. I have two, but I created a separate one. Here you can choose the replication between the data centers that I mentioned. So very useful information. And here you can select the Azure Virtual Network LAN configuration. Also, yeah, when you haven't got any, you need to create that one. It's required, as mentioned before. Here you need to create the replication policy. So you can name it randomly, RPO. So just set RPO is the difference between on-premise and your replicated environment. You can choose to create snapshots and the multi-consistency point snapshot time. So now it's the replication policy is being created. So as being said, I speeded up everything a little bit. So normally that would take 2-3 minutes. So let's wait when it's finished. Okay. Replication policy is created. And here you can actually choose to download the Excel sheet, the capacity Excel sheet, but I already did that, so I can skip that one. Now we're gonna discover the servers on the vCenter server. So here I select all the configuration parts, the vCenter service account. Here I again repeat the settings, but they are all predefined, so I don't need to choose anything else. They are all taken over from the first prepare infrastructure. Here I need to select all my servers that I want to replicate. This is the connection to the vCenter environment. Here I can select the server account and which disk I want to replicate. Now I only have one disk, so I keep that simple. Here I choose for replication policy. Here are the default settings, and here I can choose for multi-consistency. I don't use that for this demo, but keep that in mind. So all the check marks are green, so that's good. Enable protection. So now actually the mobility agents, the replication agents are being installed on the servers. You can see the status over here, and on the enable protection, the actual mobility agent is being deployed, which you can see over here. So also speeded up this a little bit, so you can see it. It took about 30 minutes of duration. So normally it is not so fast that I want it to be. So okay, that is all fine. Okay. And now all the servers are replicated over the internet. So I speeded up this, but normally, depending on your throughput of your internet connection, that can take up a while. Here you can see that your disk is synced. Last time synced is 5 minutes ago, so the RPO is 50 minutes. So this actually is great. And here you can see the source server, the process server. And here you can use the hybrid use benefit. You can use the new computer name in Microsoft Azure. You can configure here all the computer network settings that needs to be deployed when you perform a failover. Here you can choose the sizing, availability set, and use manage disk, for example. And on the network properties, you can choose to apply a VNet, subnet, or a predefined IP address, just to make sure that you're working with workloads and with the recovery plan, so you know which IP which user will get in Microsoft Azure. And this is the hybrid use benefit program.
Thanks, Christian. Right, so I've got a lot of content to cover. I'm conscious that we are incredibly pushed for time, so I'm going to try and rattle through it as quick as I can. Just a thing on the demos, I've just been speaking to Stephanie, and she's going to put some YouTube links up with all of the demos that we've got in the slide deck, which will go out to you all afterwards.
Okay.
So let's get going. What is NetScaler and GSLB? So GSLB in full stands for Global Server Load Balancing. Essentially, it's the ability to control how traffic flows between 2 or more separate physical data centers using NetScaler. the mechanism used in GSLB is Microsoft DNS, and how the client gets the response to a specific DNS query. It can be used for various different scenarios. So it can be used for load balancing, high availability, or indeed disaster recovery, as Christian was just talking about. If we were to take a basic example of storefront, if you had a pair of storefront servers in your on-premises data center, and that was sitting behind a NetScaler load balancer, you could build the equivalent in Microsoft Azure and then front that with GSLB to fail services over seamlessly between your on-premises environment and Microsoft Azure. If you had a single server failure in your on-premises DC, your GSLB domain would still point to your local data center because it would see the virtual server as being live. However, if you lost both servers on your local data center, GSLB would know about that and instantly fail you over to your storefront service running in Azure. One thing which Christian touched on earlier, when you are setting up GSLB, you assign domain names to the GSLB vServers. It's important to keep the TTL low on those domain names so that you can, the failover in the event of a failure will be fast. If we look at the components that make up GSLB, one of the most important ones is ADNS. So this is the authoritative DNS server, and it runs as a service on the NetScaler, and it will run on TCP or UDP or both on port 53. This service is responsive, so your base DNS name that you want to use for GSLB, you would delegate to the ADNS services, normally two running on your NetScalers, one on premises and one in Azure. And the ADNS service is going to query the GSLB database on the NetScaler and then return an IP address for the current live service. Like I just said, it's definitely recommended having two of these and delegate the domain name to both. This is it will just make sure that the ADNS service will still be able to reply with a valid response if you lose an entire data center rather than just one NetScaler. There's also a GSLB site or subnet IP. This is a unique IP address that is owned by the NetScaler, and it's used to share monitoring data using the metric exchange protocol between the NetScaler. So your on-premises NetScalers, it will know the state of the GSLB services running in your Azure Cloud. And it's important just to understand the difference between a GSLB virtual server and a regular virtual server on a NetScaler. So a regular vServer, they're generally used for load balancing traffic between one or more backend services. You can apply a lot of different config to a regular vServer on a NetScaler, such as kind of SSL settings, policies with rewrite or responder, etc. The GSLB vServers, they're used for monitoring the state of a specific backend vServer or service. And this is done by binding the vServer to a GSLB service, which has a monitor bound to maybe monitor an existing vServer on a NetScaler. And the service will then return the current state of that specific service being monitored. And lastly, methods. There's different methods of using GSLB. You can use least connection. You can use lowest distance or nearest location. This will take into account the client IP that they're connecting from, and it will use a GeoIP database that you load onto the NetScaler to determine whether the user is connecting from, and then direct them to their nearest active GSLB service. One thing that isn't up on the deck here that's also useful and worth looking into is spillover. So this is the ability to use a mechanism to fail over GSLB in the event that you hit a threshold. So if you have a certain capacity headroom in your primary data center, you can hit that and then fail over to a secondary data center using spillover. Next slide, please. So this slide is in here because GSLB is really all about DNS. It's not like a traditional load balancer. The GSLB vServers themselves don't have visibility into the traffic running through them. They're just responsible for passing back a relevant IP address based on the state of the services running in your on-premises or in your Azure data center. If we look at a typical scenario, a user would request storefront by typing storefront.company.com into a browser. This would then contact their defined DNS servers on the endpoint they're using. Those DNS servers have had that zone delegated to the ADNS servers on both your on-premises and your Azure NetScalers. So it will hand that DNS request off to the ADNS service. This ADNS service on the NetScaler will check the GSLB database on the NetScaler, find out where the active service is running, whether that's in your primary data center or in Azure as a DR or HA capability, and then it will return the IP address of the vServer to the endpoint. And at that point, the user will then connect directly to that virtual server. It won't go via the GSLB vServer. Next slide. So, quick slide on why is NetScaler GSLB the best option. So, as Christian was just talking, Azure Site Recovery, replication of NetScalers isn't possible currently to Azure. That may well change, but that's not there right now. If you use NetScaler on premises and in Azure in an active passive mode, you can have a very, very small footprint in Azure, acting as a disaster recovery site for your primary data center. And in the event of a failure, it will then drop you from your on-premises data center out to Azure, and then you can scale out your compute in Azure using any kind of automation or runbooks or anything you want to build that compute layer up. But you can have a small footprint of essential infrastructure there and ready to go, and good to serve your users in the event that you lose your primary data center. Also, there's a GSLB wizard since NetScaler version 12. Sorry, Chris. Since NetScaler v12, there's a GSLB wizard, which makes configuring GSLB a lot easier, especially if you're a first-time consumer of the service. It will guide you through setting up your site services, vServers, and domain names, and also your ADNS service, which you can see in a demo that will get sent out by Stephanie post this webinar. Also, Azure now supports multiple network interfaces and multiple IP addresses on virtual machines in Azure, which is the reason that GSLB is possible now, and you can use Azure as a viable disaster recovery option. So looking at what NetScaler options are available, they can be found in the Azure Marketplace. This is on the Resource Manager portal, not the Classic portal. You can get VPXs for Standard, Enterprise, or Platinum Edition. They are available in both bring your own license models and also pay per hour licensing. So depending on whether you have licenses that you want to deploy to your NetScalers in Azure, or if you don't, then you can just opt for pay per hour licensing. They offer VPX 10, 200,000, and 3,000 model variants. You can use SD-WAN Standard Edition in Azure, but this is only a bring your own license model. And also there's a NetScaler NMAS agent appliance. If you've not looked at NMAS, I would recommend you do. The NMAS agent is a go-between between NMAS that's hosted in Citrix Cloud and your NetScalers that will be present in Azure, and they will pass back information and metrics about what's happening on your NetScalers in Azure and send that up to NMAS in the Citrix Cloud. Next slide. So just looping back to the multiple network interfaces and the multiple addresses, there's two different ways you can do it. You can have multiple IP addresses on a single network interface. in a VM in Azure, or you can have multiple network interfaces with individual IP addresses. It's really down to your use case, which one you use, but configuring the multiple IPs on the same NIC are easier to use from a GUI point of view, because you can all you have to do is open up your VM, go into the network interface, go into the IP configs, and add a new static IP config onto your NetScaler, and then that IP address will automatically be available to use as a vServer or a service such as ADNS on the NetScaler. You also need to add the relevant network security group rules and bits and bobs like that to allow traffic to hit that IP address, but it's a very GUI-driven method to add additional IP addresses. Using the extra NICs, that needs to be done via PowerShell. The commands are up there on screen. I'm not going to walk through them all. You will get the deck afterwards and you'll be able to see how you can do that, but that will add an additional network interface to the VM, and you can add an IP address for that. The IP addresses will have to be in separate subnets if you go down the extra network interface, as opposed to the multiple addresses on a single interface. If you're doing option 1, you can have multiple IP addresses within the same subnet on a single NIC. Just a little bit of additional information around networking requirements that you're going to need to run a NetScaler in Azure. You will need port 53 for TCP and UDP open, obviously for the ADNS service, and you'll need port 3011 for metric exchange protocol between your NetScalers. And obviously any service you want to provide from your NetScaler in Azure, you'll need to open those ports inbound so the users can connect to it. So this is just how does it work? It's the configuration. So this is what you would go through to configure GSLB on a NetScaler generally. First, you would configure an ADNS service and your vServers that you want to load balance. Then the first thing would be to set up your GSLB site, and you would have either a local or remote site. And you would define this on both pairs of NetScaler. So for your on-premises, you'd have local and remote in Azure. And on your NetScalers in Azure, you would reverse that. Then you would configure your services. This is also the same. The services are there to monitor existing infrastructure, either on-premises or in the Azure data center. Then you would configure your active and passive GSLB vServer. And then generally you would bind the passive one to the active one as a failover. If the config is then done, you can look into the GSLB dashboard, synchronize the sites, and actually test the failover. Next slide. This is just a visual display of how that would normally work. I'm not going to walk through this right now, just because there's some other slides coming up which will show you how the traffic flow would work. Right, so this is traffic flow in a normal operation. Carsten, you're going to have to push next while I do it. So the first thing is you would make a request to the DNS server. Then this would then drop to the ADNS service being delegated to the NetScaler. That would then check the GSLB database and query the services. It would then come back with the active GSLB vServer for that service, for the domain name. And then it would return the IP address of the currently active service that you want to load balance. So if we lost ADNS service in a single data center, again, you would type in storefront.company.com. This would hit DNS, which is then delegated to the ADNS service. This would then query the GSLB database in your Azure Cloud, which has visibility of services running on premises. This would then return the GSLB vServer for storefront in your on-premises data center. and the user would get back the IP address of your on-premises storefront service. So then if we lost our entire data center on premises, the user would type in storefront.company.com. Because we've delegated that to both on-premises and your Azure ADNS service, it would query DNS. It would get handed down to ADNS in Azure. This would then query the GSLB site database on your NetScalers running Azure. It would know that the primary is down, so it would send back the IP address of your storefront service running in the cloud. Next slide. And this is a demo of the, or that was a demo of the GSLB config wizard, which, as I said, we will pass out on the slide deck post this webinar.
Sorry for being late. I had some technical problems.
Over to you.
So now I'm there. And we'll talk a little bit about tips and tricks if you're using NetScaler on Azure. First of all, very important, I think, is monitoring on NetScaler services running in Azure. Therefore, Dave already mentioned it. You have got NetScaler management and analytics services, and the agent is available right now on Azure in version 12. Therefore, you need a management service server on your data center side, and the communication will be on HTTPS. Other way, you can use SNMP or syslog or protocols like this to monitor your NetScalers running in Azure or running on-prem, so that you get information about your status and about GSLB and if your services are up and running. Furthermore, you need to back up your NetScalers. This is also very important for NetScalers running in Azure, because if you want to update them, you have to redeploy them, and maybe you want to use your backup to redeploy your NetScaler. I figured out that there's no documentation available on eDocs on Citrix to update your NetScaler, and there's also no special download to update your Azure VTX. So, in my opinion, there is a special build for Azure, and this is not available for download so that you can upgrade your NetScaler on your own. You have to redeploy it, and therefore a backup will be helpful. Otherwise, you can automate your NetScaler, and I will go deeper on this later. Next, please. So another important thing for me is to make sure that your NetScaler in Azure running in the same availability set. An availability set is a set of virtual machines, and Microsoft will make sure that they are not running on the same compute and storage resources in Azure. So if you have problems with your compute power or storage power in Azure, it will be only affect one of your NetScalers if you have two NetScalers running in Azure. Next, please. Here you can see how to create an availability set and which settings you can make on your availability set. It's really easy to configure it, and then you have only to use this in your deployment if you are deploying your NetScaler. Next, please. So this is what I explained to you. You have different compute clusters, and your virtual machine is running in one availability set. And if the storage is failing or something like this, you have the same machine, a different machine running in this availability set. The storage from the second machine will not be affected. And so my tip is to use availability sets for NetScalers running in Azure if you have more than one in Azure. Next, please. So, as I mentioned, updating a NetScaler in Azure is not that easy because you have no special build for it, and therefore I figured out you can automate as much as you can. The first thing to automate a NetScaler deployment in Azure is to use a template. On the right side, you can see a sample template which I configured to deploy NetScaler on Azure, and I will show to you that you can use different availability sets. You have to configure them first and just type in the default value, and this is the name of your availability set. There are also some settings for different network interfaces. You can see in the lines below. There's one network which is running a subnet which is called access, and the second network interface is running in a subnet which is called server. Next, please. Okay, Dave mentioned about different network interfaces and IP configurations. This is also something which I covered in my template. So you can do your IP configuration directly in the template and configure some different IP addresses for the different network interfaces you can use on Azure. And so this is much easier if you redeploy a NetScaler. You only use your template and deploy a new NetScaler, and everything is already configured automatically. On the right side, you can see the IP configuration for a management and for a backend IP address running on the same network interface. And below, there's a second network interface with a different IP configuration for the front-end communication. So this is a template to split up front-end and back-end communications in your NetScaler, running with two network interfaces, one with two IP configurations, and one with one IP configuration. And it's really easy to work with the template because you have to copy and paste the specific lines and then just add some comments, type in some names, and that's it. Next, please. Yeah, another way to automate your NetScaler on Azure could be PowerShell. I will not go deeper into this because there will be an upcoming webinar with Esther and Dave. I don't know exactly the date. I think it will be sent to you by email. And they will talk about how to automate NetScaler with PowerShell. And you can use this as well for your NetScalers on Azure. Next, please. Yeah, and for all of you who want to download the template, I have added a short link, and there you can download the template and deploy your NetScaler on your own with this template. Oh, just so the webinar will be on September 28th. Next, please. So one important thing for me is to think about your security in Azure, and therefore you have some different parts you can use. For example, there are security groups, which is a kind of a firewall policy, which you can configure in different ways. So you can bound it to a network interface, or you can bound it to a subnet. So the first policy will be which will be matched is the policy running on the subnet. So if you configure on the subnet, traffic on port 443 is allowed, and you will deny it on your network interface. The priority of the network interface will be higher, so traffic on port 443 will be denied. So this is very important to know that you configure maybe different subnets in your Azure account to bind different rules directly on a subnet. So if you want to have front-end communication running only on port 80 and 443, just use the subnet and configure a network interface of your NetScaler running in this subnet, and configure a security group for this subnet, which allows communication on port 80 and 443. And then you have got your second network interface, which is running on a different subnet for your backend communication. And there you can configure DNS communication, NTP communication, and LDAP, and so on. Next, please. And another point is maybe if you are using high security environments to use different subscriptions to encapsulate your NetScalers in an access layer, which is a different subscription than your compute layer where the servers are placed. So that your compute power cannot directly connect to the internet, and you don't need to configure, or you don't make any failures if you configure subnet policies so that you are directly connected to the internet. So you can split this off and use an access layer and a compute layer in different subscriptions to get a higher security. And then you need a routing instance which will route the traffic between your servers and your NetScalers. So I think this is only a solution for high security, but I will point out this is possible if you want to use GSLB or NetScaler Gateway running in Azure, that you can use also a high security. Next, please. And the last point, if you think about your security, think also about SSL security for HDX communications. There's a good blog article which I mentioned below. Use this if you want to secure your HDX communications. Next, please. Yeah, another point is think about cost reduction. So which machine size do you really need? If you have only a few users, a single core machine with only 4 gig RAM will be maybe enough. If you need more users, you need a bigger machine, and this is the price, and this is the cost you can reduce if you use the right machine size. Also use the right license. So there are different licenses available. Dave mentioned it, and choose the right one. Maybe a better way is to use the licenses within the Azure subscription. So maybe use a VPX 100 license, which is offered to you by Microsoft. And then if you don't use it again, turn it off and save money, maybe for the weekend. And one important thing for me in Azure is don't use high availability. Use instead GSLB, because you need maybe smaller machines with smaller licenses, and you can reduce your costs instead of using high availability. Next. And of course, do some load testing on your machines. So if you want to know which size do I need, which license do I need, and so on, use load testing tools like ControlUp or Login VSI. If you don't use this, you will end maybe in this picture. Could you click again? So your NetScaler will be fully loaded or overloaded. So I'm done with my tips and tricks, and will hand over to Christian again.
Some useful study tips on Microsoft Azure. First of all, I would like to introduce the Microsoft Developers Essentials program. This is a program that is free to use for developers with a Microsoft account that provides essential Visual Studio program with free Azure credits of $300. What can be used in 12 months. Normally, when you activate a trial in Microsoft Azure, you are limited to $180 for 1 month. So yeah, for testing purposes, that is very short. One other advantage is the Purple Site 3-month free subscription. So with that Essentials program, you are also able to activate Purple Site for 3 months. So with a lot of great Azure video content to be shown to you. And also the Microsoft Virtual Academy is activated in the program. So take a look at the subscription link. It is very interesting to get a hands-on experience with Microsoft Azure or Site Recovery or infrastructure as a service, the virtual machine service, for example. Some useful blog articles from Dave Brett and from me regarding this presentation are the following 3. Please take a look at the links if you want to know more in-depth initial configuration information about everything that we just discussed at this webinar. So now we switch over to the Q&A. I don't know how much time we have left to use that, but Stephanie, I guess we are using the blog post afterwards for answering all the questions.
Yeah, I thought we could do that. We could get to the questions that maybe didn't get answered. We'll put those in the forum and also put the ones that did get answered so that everybody else can kind of see what was asked. And also invite everyone that if you still have questions, please type them into that forum thread and they will get answered.
Yes, that would be great. So switch over to the last slide. A little bit of drums on the background, but we also have a competition quiz, as I mentioned in the agenda slide. And the fastest person that actually gives the correct answer wins an actual My CUGC t-shirt, officially from the Synergy Congress of this year. Who knows the correct answer of this question wins this t-shirt, and it will be sent to you after the session. So is someone giving the right answer?
Not yet. So if you just type your answers into the question panel, and whoever, like you said, the first one is the winner. I'm keeping an eye.
I think Tim was the first one.
Yep, I just saw that.
Okay,
congratulations, Tim. Hey, Tim. I might have a synergy.
Okay, great. We have a winner. So it was actually Machine Creation Services. So congratulations, Tim.
Tim was also one of our CUGC members of the month.
Okay, great. Awesome. He has to do a webinar also.
All right. Well, if you guys are all wrapped up, I'll take it back for just a moment. Thanks again for your presentations today, and thanks to everyone for attending. I'm putting a link in the chat window now to a very short survey. We always use it to your feedback to help plan future webinars and content on mycugc.org. And just want to invite you all to come over to mycugc.org and check out our upcoming webinars, including that one with Dave and Esther that was mentioned. So that means Dave owes me some information. We'll have that up on the site soon. And thanks again. Thanks, guys. We really appreciate everything that you do.
Okay, no problem.
Thanks, Stephanie.
Thanks, Stephanie.
All right, everyone have a great afternoon, and we'll see you back at another CUGC event soon. Bye.
Bye.
Bye.